Welcome back. This is now for day two. On day two, we went through an activity to kind of walk through the scientific method. I'm not going to do that activity with you now, but we went through testing a hypothesis, what our independent and dependent variables are, how to operationally define those variables, what kind of study we should do and who we should test, what the data looks like and what we kind of learned from it, what it looked like in a chart to like help us draw conclusions, and then finally what it looks like to report the findings. So I don't want to run through that now with you because there are other things we have to do, but this set of notes is going to be a little bit shorter because we're just going to skip ahead to talk about an experiment and how experimental designs work. So there are a couple things you need to know about experiments that make them very particular, which is why they're the only ones that can establish cause and effect. So we're going to start by talking about the different groups that you need to run an experiment. So in an experiment, you need two groups, the experimental group and the control group. The experimental group gets the treatment in regard to the independent variable. So that is, in the case of the example on the screen, the kids who listen to music in study hall, because that's something that they don't normally get to do in most study halls that actually treat them like real study halls. It's anything that happens to that group. So if it's you're testing a new medicine, it's the group that actually gets the medicine, for example. The control group, on the other hand, are similar subjects that do not get any special treatment. So it's the kids who don't have music in the study hall and are just regularly studying. It's the people who don't receive the medication or receive a sugar pill instead. Anyone that doesn't get the special treatment. And it's important to know that these two groups have to be the same. We can't just split a group down the middle and call it a day. You have to make sure that the groups are randomly assigned. We use random assignment. So everyone that's in your study has an equal chance of being put into either group, either the experimental or the control group. So it's really important to keep this in mind as you move forward. And if you ever get to do your own psych studies, depending on how the world is by April of next year, you'll have to pay attention to making sure people are randomly assigned to your groups, because that way you can get rid of some of the differences between groups. One of the other things to keep in mind, and something that is helpful in terms of random assignment or mitigated by random assignment, is confounding or extraneous variables. Depends on who's writing them. I like to say extraneous because I like the word, but I think your book may call it confounding. I'm not sure. So confounding or extraneous variables are anything that can interfere with your results. So anything that can distract from your independent variable causing an effect in your or change in your dependent variable. Anything that can get rid of that. So if we're doing a study of happiness across America, where we call people and ask them how happy they are, one of the confounding variables we might have is the weather outside. People tend to be happier when it's sunny out and sadder when it's raining or cold. So it's really going to be dependent on what day you call, and that's going to change how people feel. People also generally are more happy towards the end of the week than they are on like Monday, for example. So another confounding variable could be the day that you call them or even the time that you call them. There are so many factors that can interfere with establishing cause and effect, especially in this experiment. So it's just something to keep in mind as you're going through things. There are also some biases in experiments that we need to talk about as well. And I will explain the ways to fight these biases, but it's basically going to go 3, 2, 1. And we'll go over them all together. So there are a couple biases we can control and some that we can't. So we'll start with the ones that we can control. And the first one is subject bias. And subject bias is when a person who's participating in an experiment, so the subject or participant, acts in a certain way in the experiment. It might be to look more favorable to the experimenter. It might be to help them out. It might be to screw them over. Like I said to some of the classes, I don't even remember which ones. In college, you can often participate in psych studies. And if you know the grad student who's doing the psych study, you can mess with their experiment and their results pretty easily. And there are ways to avoid it. And that's using all three fighting biases options. So deception, single blind procedure, and double blind procedure. And we'll talk about those in a little bit. But you can use all three of those to kind of counteract this idea of, people doing what they're not supposed to be doing and acting in a certain way just to change the experiment. Expectation effects. These are the subject's beliefs about uh, what they're supposed to feel or experience, and that can actually influence what ends up happening. So, if you're doing a trial for a new headache medicine, for example, and you are in the group that's receiving the headache medicine to try and get rid of your headache, you might believe that it's going to help and you might actually feel better whether it works or not. Your brain will say, oh, we took this Advil like pill and now we feel fine. And that's an expectation effect when it might not actually work for most people. So those kinds of things can also interfere. And one of the ways we can counteract that, or I guess two of the ways we can counteract that, are using either of the blind procedures, so the single or the double blind procedure. And we can help counteract that idea of the expectation effects in some cases. Fortunately, not in all of them. And the final one is the experimenter bias. And this is looking for results that confirm your hypothesis and then ignoring results that disprove it. This can often happen if you're trying really hard on something that you really believe in and it's just not going the way you want. And sometimes people are just like, oh, those are outliers. Let's ignore them, which is not okay. It's not what you're supposed to do. One of the ways to avoid that is to use a double blind procedure. So that is something that can help you avoid the experimenter bias as long as, at least the researcher really knows what's going on. For the biases that we can't control, but really the big one is the environmental effects. In general, people tend to act differently when they come in to to a lab to do an experiment. You can't really change that. You can't really change what the weather's like outside and how that'll affect someone's mood. You can't change a lot of stuff like that. But you can keep it in mind as you move forward and you can account for it when you're going through things. So, how do we actually fight these biases? The first is deception. Deception is, we're going to talk about it a little bit with ethics, but it's basically not telling people what the experiment is actually about. You're withholding some truths. So, lie by omission rather than straight up lying to someone. Because you're not allowed to straight up lie to someone. But if you're testing things like prejudice, you probably don't want to tell people they're testing prejudice because then they're going to act in a certain way. Maybe you're going to tell them, I'm testing your reaction time to something. And they might say, oh, okay. And then you can kind of learn something about them from there. In a single blind procedure, this is when the participants don't know whether they're in the control group or the experimental group. This can be hard for some experiments. Like, think of if we were to do an experiment to see if gum or chocolate or nothing helps you remember information by the time you get to the test. It's very easy to know whether or not you're smelling gum, you're smelling chocolate, or you're smelling nothing. So we can't really do a single blind procedure there. But if we're doing a trial for the headache medicine, we can kind of see whether or not the headache medicine works if we also give you a sugar pill to the control group, which we'll get to on the next slide. Finally, the double blind procedure. This is when neither the participants nor the experimenters know which group is which. So this is like, you'll have all of the people who help you out. So those are called Confederates, not like the US history Confederates. Confederates in psychology are people who help you in a study. Usually they're people who are like research assistants or something like that. And they help you participate in various ways. And those people won't know who's in which group, but maybe the head researcher does, and they have like a master list to be able to look at it. And you can't really have a bias if you don't know who's actually in which group. So then one of the ways that we would keep the group separate in terms of single and double blind is to keep everybody in the dark using placebos. These placebos are sugar pills that look like the experimental treatment pills. So they might look like the headache medicine that we have. They don't cause any reactions, and it makes everyone think they're in the experimental group, which is great, except for the fact that expectation effects might kick in. But we get to see which group actually does get better with treatment. However, there's something called the placebo effect, and this is when people receiving placebos actually report feeling better, even though they didn't get the experimental treatment. And it's really one of those things that your brain tells you, like, oh, we got better, and it just feels like you did, even though nothing really changed. That's why we call it the placebo effect, because it's a fake feeling of it, but your brain just can't tell it apart. And this is where we left off on day two. So we talked about this slide and then kind of moved on to prepare to talk about correlational research next class. But some of the advantages and disadvantages of experimental research. The first big advantage is this is the only one that establishes cause and effect. You have control over everything. You can tell what the relationship is between variables because you can isolate that relationship and focus on it. But one of the big problems is that it's really artificial. It's often in a lab setting. These aren't situations you'll find in real life. And the more accurate you make it to real life, the more you start encountering confounding variables, which will make it harder and harder to study and harder to prove cause and effect. And because it's artificial, it's really hard to generalize it. You might react in a very different situation if the situation was slightly changed. So it just depends. Studies can often be time consuming, or experimental studies, and also expensive because you do have to pay your participants because people don't work for free. Um, and then finally, of course, ethics are a big thing. There are just some things you can't test, like poor diet by a pregnant woman on a fetus. You can't bring in a bunch of pregnant women and starve half of them and then say, oh, this is how it works. That's literally horrible and unethical. And when we get to the ethics part of this unit, we'll talk about some of the most unethical studies and how that happened and why that happened. So it's really important to, make sure you're sticking in line with the ethical guidelines. But we'll talk about those later. And then this is where we left off on correlational studies. That's where we'll pick up on day 3. Bye, guys.